welcome to the last section in chapter 2. Here are the solutions for 2.6. Make sure you check over those proofs. Let me know if you guys have any questions as always. Here is the proof for, here's number 20. It said challenge, but if you break it up, wasn't too difficult, I don't think, but if you have questions on this, let me know. And then here's 22, this was a proof. And I have 23 crossed out. You can use this here. I did it slightly different than the book. Here's how I did it. A little bit different, but both proofs would be okay. This just kind of makes a little more sense to me, so I did it this way. All right, we're going to prove angle pair relationships. A lot of this is going to be review, or it's going to seem review, but we've talked about it, but we're going to actually prove statements today. So the first thing is the right angles congruence theorem. All right angles are congruent. So given that 1 and 2 are right angles, we're going to prove that they are the same. This is very trivial. Okay, so we're given that these are right angles. Well, if 1's a right angle, it's 90 degrees. 2's a right angle, the measure is 90 degrees. That's just the definition of a right angle. Now, because 1 equals 90 and 90 equals 2, then 1 has to be equal to 2. And finally, the last step is an interesting step. This step right here, from 3 to 4, is a critical step that takes a little bit to figure out why it works the way it works. But 1 is congruent to 2, and that is the definition of congruency. Their measures are the same, therefore they're congruent. And we're trying to prove that they're congruent, not that the measures are equal. So this step here is odd. Odd, but necessary. And that's going to come up a lot, so you'll get used to it over time, but it seems like redundant. Okay, what's true here? Okay, well, 153 and 28, these add up to 180. And 153 and 27, those add up to 180. And then these two angles must be the same. So this is, again, this seems really intuitive, but it's actually really important. These are two different theorems that can save us a lot of time in the long run. It says if two angles are supplementary to the same angle, or congruent angles, then they are congruent. So 1 and 2 are supplementary. So these two are supplementary. And these two are supplementary. Then these two have to be congruent. And it works the same thing for complementary angles. If these two, 4 and 5 are 90, and 5 and 6 are 90, then 4 and 6 have to be congruent. So those are important. They may not seem important now, but they will be. This makes a really mean face over here. It looks kind of scary. Okay, let's prove one of these. Given that 1 and 2 are supplements, 3 and 2 are supplements, we're going to show that 1 and 3 are the same. So I'm going to start with my givens here. All right, 1 and 2 are supplements, 3 and 2 are supplements. Well, if they're supplementary, we know that they have to add up to 180 degrees, definition of supplementary angles. All right, so 1 plus 2 equals 180, and 180 equals 2 plus 3. So the transitive property is going to say that 1 plus 2 equals 2 plus 3. Okay? And what I'm seeing on this statement right here is I'm seeing the measure of angle 2 on both sides. So what we can do is we can subtract that value from both sides, and we're left with the measure of angle 1 equals the measure of angle 2. And now, again, that last step, I'm trying to show that they're congruent. So I actually need to do one more step here. This is that weird step that you'll get used to. Definition of congruency. So I'm obviously going to say definition of congruency. The measures are equal, the angles are congruent. And the same goes for segments. All right, linear pair postulate. We've talked about this a lot this year, except for now we're going to formalize it. If two angles form a linear pair, then they are supplementary. Now this is a postulate. We don't need to prove this. All right, and then we have the vertical angles theorem, and we've talked about this as well. If two angles are vertical, then they're congruent. So 1 is congruent to 3, and 2 is congruent to 4. All right, we're going to prove the vertical angles congruence theorem. So given 5 and 7 are vertical angles, we're going to show that they are congruent. So we're not really given a lot of information here. That's our given, but it doesn't help us with anything. So we gotta look at our picture. And what I'm seeing with my picture is I'm seeing some linear pairs. 5 and 6 are a linear pair. And 6 and 7 are a linear pair. So I'm gonna write that down. Definition of a linear pair, shown in the diagram. You can also just say given diagram too if you want. So if you want to say given / diagram, that's okay there. Now, if they form a linear pair, we just formalized that they have to be supplementary from the linear pair postulate. This is used a lot. So if they're a linear pair, they're going to be supplementary. Now, you're probably going to say, why can't we just say that they're equal to 180? Because first we have to use this and say that they're supplementary. After that, we can then say, oh, actually, this is quicker. If two angles are supplementary to the same angle, then those angles must be congruent. Now, I said this will save us a lot of steps. This guy right here is going to save us a lot of steps because I always forget about it. Even as a teacher, I always forget about it. Okay, oops, sorry about that. Let me go back here. Give me 1 second. I have to click through some things. Okay, so since 5 and 6 are supplementary, 6 or 7 are supplementary, it makes 5 and 7 the same. What I was gonna do is I was gonna say 5 plus 6 equals 180, and then 6 plus 7 equals 180, and then 5 plus 6 equals 6 plus 7. Subtract the 6 is left with 5 equals 7. So that's what I was gonna do, which takes a lot of time. This is much quicker. So there you go. I'm glad I remembered that. Okay, and the last problem I'm going to go with is which equation can be used to find x? And here we have a linear pair, so we know that these two angles have to add up to 180, so 32 plus 3x plus 1 has to add up to 180 degrees. And so that would be option B. Alright, that is all I got for you guys today. Here's your homework. Make sure you try the proofs at the end as always and see me if you have any questions. Thank you for tuning in to